All right, we are rolling. So take out please your practice tests. Chapter 3. And let's see what we have.
Really?
First I'll read off, actually you've got the answers already, so I don't need to read those off. I am open to questions. And a second. Just open up the correct worksheet. Got it. 23. There we go. Just so I know I'm at the same version, does the first problem say 2x squared minus 4x plus 4? Good. Okay. So you have the answer. Does anybody not have an answer key yet? Question. You're not, weren't you yesterday? Yeah. Okay. Anybody else not have one? Speak now or forever hold your peace. I am posting the notes on this to YouTube. No problem. So if anybody wants to get a second run through, click like and subscribe. So, I'm at your disposal. What questions do you want to see? Go.
14.
14. Okay, implicit differentiation. 14 looks like this. 5x plus y squared plus 4x cubed equals 2. And they want you to find dy over dx. So what do you do first? What does d mean when you're doing dy or dx?
Take the derivative.
Derivative, exactly. Take the derivative as it is, just leave the dx's and dy's lying around. So you tell me, what's the derivative of 5x?
5.
Okay, 5, and then followed by?
Dx.
Good, dx. Plus what?
2y dy.
Very good, dy plus?
12x squared.
Good.
Dx.
Dx equals what?
0.
Very good. The derivative of 2 is 0, it just disappears. Okay. So what do you do now? Sam, take over.
We're trying to get dy by itself.
Correct. You want to get dy of itself first.
I guess you could subtract 5 dx.
Okay. Subtract 5 dx.
12x squared dx.
And subtract 12x squared dx on the other side. So you should have 2y dy equals negative 5. Actually, I'm going to put that. It doesn't matter what order you put them in. I just like having it in descending order. Negative 12x squared dx plus negative 5 dx. And those can be swapped around. That's totally fine. Now what? Blaze, take over.
Divide by 2.
Divide by 2y, definitely. As long as you do it to both sides. And I would do it to every single part. It's totally up to you if you want to do it all over. You could also do it or negative 12x squared dx plus negative 5 dx all divided by 2y. That's fine. That's totally fine. Either way is fine. So these cancel. And there's one other thing I'd like to do.
Divide by dx.
Divide everything by dx. Cancel, cancel. So you should have dy by dx equals, is anything reduced in here?
E equals to negative 6x squared over y.
Yeah. And then plus
Negative 5 over 2y.
negative 5 over 2y. Correct. You could also, if you did the other version, you could just write it as dy over dx equals just plain old negative 12x squared, if you divide everything by dx, plus negative 5 over 2y. I'll accept that. Either way is fine. Just make sure that the dx's cancel. And beware of the plus sign here. A lot of people say, oh, look, a dx and a dx, I'll just cancel these. you gotta cancel both. Dividing the whole thing by dx is the same thing as dividing each one by dx. So it is a little bit safer to split it up when you're canceling, although you don't have to. Does that make sense? Think you could do that on a test? Next. Yeah. 12, let me look. Okay. Y equals sine of 2x squared. Let me put it over here. I'm gonna put parentheses here. They're optional, but they make it look better. What, Sam, what's the derivative of sine? Cosine. While we're at it, what is the derivative of sine of x? How would you write that? Go ahead, Sam. What's the derivative of sine of x?
Cosine of
And if I use d notation, what would I put at the end? Dx, good. The only time I don't write dx is if you divide it in front, or if you use prime notation, which is secretly dividing in front. No names, never mind. Denied. Sorry, Nate. Josh, what is the derivative of tangent of x? These you need memorized. Okay. Nick. Okay. It is secant squared. Secant squared of x dx. What is the derivative of secant of x? Who's feeling brave? At least these three need to be memorized. The other three you can figure based on these. But, have we got it? Derivative of secant. It's a double one. Yeah, Josh. Secant of x, tangent of x. Secant tangent. Derivative of secant is secant tangent. So these three are the basis for the 6 trig derivatives. Derivative of sine is cosine. Derivative of tangent is secant squared. Derivative of secant is secant tangent. I would say memorize those. Can you derive them? Yeah, using the quotient rule and things like tangent is sine over cosine, you can do quotient rule. Secant is 1 over cosine, you can do quotient rule. It takes a while. It takes like 5 to 10 minutes to derive it. So it's much easier to memorize. Questions? What's the derivative of cosine? Go. Negative sine of x dx. What's the derivative of cotangent? Yeah, Sam. Negative cosecant. Something missing. Parallel it with this. Before that. Tangent goes with cotangent as secant goes with cosecant, but it has to be squared. It's identical to the top three. The top three and the bottom three are parallel to each other. You just switch it to its co-function. Sine switches to cosine, cosine switches to sine. Just remember, when you take the derivative of a co-function, the answer is negative. Just using the pattern, can somebody deduce the derivative of cosecant? So secant goes to cosecant, do the same trick here, but make it negative. Hang on, what do you think? Secant would switch to negative cosecant, and then tangent pairs up with. So sine goes to cosine, tangent goes to cotangent, secant goes to cosecant. So you switch the secant to cosecant, what are you switching the tangent to? Cotangent, exactly. Those are your 6 trig derivatives. If you know the first 3 by heart, you can do the negative cofunction to get the answer on the other 3. Questions? Okay, back to the original problem. y equals sine of 2x squared. Now there is some extra junk in here. I would call this the sine of blah, the sine of something unknown. So I want to find y prime. What rule are we going to need here? Right. The three main rules are product rule, quotient rule, chain rule, and then the easy ones. Chain rule, very good. Chain rule means you have a function inside a function. When you have layers, what layer do you hit first? Inside or outside? Yeah, it's kind of like when you're peeling an onion. You peel the outside off first. So tell me, it's sine of something. What's the derivative of sine? Cosine. Cosine of what in this case? It would be, but not yet. It's the sine of blah. The derivative of sine of blah is cosine of blah. And then chain it to the next layer. What's the derivative of the next layer? That's it. Does that make sense? You could rewrite this. It's considered polite, I guess, to put the 4x in front. I will not require it. This is okay. This is better. But both of them are acceptable. Does that make sense? Yeah, if you have some loose change at the end, it's always polite to put it in the front, but you don't have to. And if I had done D instead of prime notation, I would have put dx at the end. Any questions on number 12? I think you could do that. Next. Yeah, go. Number one? Yeah, the one where you have to find it using limits. Let's do it. Does everybody have number 14? Otherwise, check YouTube. F of x equals 2x squared minus 4x plus 4. And they want you to find the derivative. Now, can we do the derivative just off the top of your head? Like, what's the answer that you're supposed to get? 4x minus 4, right. I mean, we can do that instantly just by the shortcut trick. But what they want you to do is, can somebody recite the formula for the limit definition of derivative? You'll need to know it in order to do this problem. Go.
F of x plus delta x.
True, but something first.
Oh, the limit as x approaches,
As something approaches.
oh, as delta x.
Delta x approaches 0. The reason they're doing that, if you remember, when you're trying to get a tangent slope, you've got a movable point where the distance between the two is delta x. And the closer you move this point, the better your tangent line is going to be. In other words, delta x has got to get smaller and smaller and smaller and smaller in order to get the 2 points closer and closer together. So we're scooting delta x closer and closer to 0. And then what's the main formula?
F of x plus delta x.
F of x plus delta x
Minus f of x.
minus f of x
Over delta.
all over delta x. That, there's no way around it. You need to memorize that as well. So there are basically 3 things you need to memorize for this test. One is the limit definition of derivative. That's this. We'll use it in a moment. The second is the trig derivatives, which I just erased. The third is the rules. Product rule, quotient rule, chain rule. And then the easier ones, which people know how to do already. So what I need to do is this. The very first thing you should write is the limit as delta x approaches 0. Now we can't calculate the limit if we're dividing by delta x, which we are. Because if you try and plug in 0, it explodes. You tell me though. I would write it like this. Big something minus big something all over delta x. would like to know what those two sum things are. Talk me through it. Sam, help me out. How do you get this thing? What does it mean? Like, how do you calculate it? Like, this part is going to correspond to this parentheses. This thing is going to correspond to this parentheses. Question, what's f of 10? How do you find it? Plug 10 in. What's f of smiley face? Yeah, 2 smiley face squared minus 4 smiley face plus 4. What's f of x plus delta x?
Okay.
Let's just do it off to the side.
It would be, 2 parentheses x plus delta x
Yes.
squared,
Uh-huh.
plus,
Minus.
oh, sorry, minus 4
Uh-huh.
x plus delta x.
Good, in parentheses. And then
Plus 4.
plus 4. That's it. You do have to simplify it, but that's what you're looking for. That's going to be here. Nick, take over. Simplify this thing for me. How? Like, what do you do first? Exponents, multiply, add? Exponents. How do you do binomial squared? Edge, I hear the whispers. Shush. You're not going to have whispering during the test. Go.
I write it down and just.
And foil it?
Yeah.
That's fine. The pattern is square the first, double the product, square the last. Square the first for me. Here's the first and last. X squared. Double the product. Product means multiply. And then double it after you're done. What's x times delta x? Don't work too hard.
Delta, x.
X delta x. Yeah, you really, it's kind of like x times y. You can't do anything with it. And now double it.
The x.
The final product. So what's x times delta x again? X delta x. Double it. 2x delta x. You just multiply by 2. And then plus square the last.
Delta x squared.
Correct. Then, help me out, Josh.
So you just distribute it.
Correct. Distribute the negative 4. Forget it's close. Negative 4x plus negative 4 delta x, and then plus 4. And then the last thing I would ask you to do is distribute that. Go ahead and do that as well.
So it'd be, 2x squared.
Uh-huh.
Plus 4x delta x.
4x delta x plus
Plus 2 delta x
2 delta x
squared.
squared. And then plus negative 4x plus negative 4 delta x plus 4. That's this. Does anything combine? Anything go together or no? If it doesn't, it doesn't. Any like terms? No, there are not. This has a delta x and this does, but this has an x and this doesn't. So really nothing matches up. So just write small. 2x squared plus 4x delta x plus 2 delta x squared minus 4x minus 4 delta x plus 4. Now what goes here? Blake, take over.
Just adding that to the
Mhm.
2x squared minus 4x plus 4,
Correct. And then what do I do with this minus?
distribute.
Distribute. Add the opposite, opposite, opposite. Everybody read so far? This thing got much, sorry. Plus 4. Okay. Let me see. Becca, take over. Does anything simplify on top? Look carefully.
The 2x squared, negative 2x squared.
Cancel. Correct. Anything else?
The negative 4x and 4x.
Negative 4x and 4x, and
4, negative 4.
the 4 and the negative 4. By the way, if you do this correctly, every single piece of the original function should cancel. They should all be gone. So tell me what's left, Becca, while you're at it. So front of x equals still limit. Limit is what?
Delta x approaches 0.
Okay. Of what? What's still surviving?
The 2 delta x squared. Oh, 4x delta x.
4x delta x plus
2 delta x squared
2 delta x squared
minus 4 delta x
minus 4 delta x, good. All over
delta x.
delta x. What do you do now? Okay. Can I plug in delta x equals 0 right now? No, still dividing. What's the cure for this? Think back to chapter 1. When you have something that you want to take a limit but plugging it in would make it explode. One is try to plug it in and see if it works, it doesn't. And then what's method 2? Something to do with the top of this thing. Something these have in common.
Pull out delta x.
Yes, there's a GCF. It's the limit as delta x approaches 0 of delta x. What's left behind while you're at it?
Oh, 4x plus 2 delta x
Right, there's a single delta x left.
minus 4.
Whoops, minus -4, sorry. My bad. All over delta x. What happens now?
The delta x. That's
Correct. Now, can I plug this in now? Yes. Don't plug it in for x, by the way, careful. Plug in delta x is equal to 0. So what do you get? So you don't need to write limit anymore because you're actually doing it.
4x
Uh-huh.
minus 4.
Yeah, 4x plus 2 times 0 minus 4, which means, there's your final answer. That's the traditional standard way to get a derivative. We have shortcuts. We have a dramatic shortcut in this case. If you know the power rule, multiply the coefficient times the exponent, drop the power by 1. That's really, really fast. But there are some problems where you must do the limit definition in order to get the derivative at all. Questions on this? So this work here is what I'm going to be looking for. If you just write this answer, everybody look up here. If you just write this answer and nothing else, you will not get credit for this problem. Just saying. I know what the derivative is. I want to know what the limit definition of derivative is. We know how to do the power rule. I want to know if you can do this stuff and how to use limits from last chapter. Okay? Next. Yeah, Sam.
Number
2.
2.
Let me scroll down. Okay. Find the equation of the line tangent to the function at the given point. Let me erase this here. We have y equals x cubed plus 8x squared plus 21x plus 18, and they have a point at -1, 4. Just to reassure you, you do not have to do the limit definition ever again, just on that one problem, to show you know how to do it. Then all the other ones, you can do whatever shortcut you want. How do you get an equation of a tangent line? There are 2 things you need. Like what? Go.
Number 2.
Derivative, what does that give you? Part of it. The tangent slope. The derivative of this thing is the tangent slope. In order to get a line, you get a slope and you also need a what? Depending on what form you use. Y-intercept, yeah, unfortunately we don't have a y-intercept or x-intercept because this is not a 0 in there. So is there a form of a line that would allow you to do this without an intercept? Yeah. Point slope. Make sure you have the point slope form memorized. That's what this is for. Otherwise, because sometimes they just won't give you the y-intercept, so you can't use slope-intercept form. So, not easily. So y prime equals, let's start there. Blaze, go for it. What's the derivative of this thing? Feel free to use the shortcut.
3x squared plus 16x plus 21.
Plus 21, good. That should give you the tangent slope. If you give it a value of x, it'll give you the tangent slope there. Speaking of which, what is the tangent slope? What value of x are you going to use? Rainey, take this one. Did they give you any value of x? Exactly, -1. You can ignore the 4 for now. Just plug 1 in, -1, sorry, in for that. Go for it. Y prime equals, just do the calculation, 3 times -1 squared plus 16 times -1 plus 21. Go ahead and do that for me.
3,
Good. This is +1, so it's 3.
-16,
Okay.
plus 21.
Good. 3 plus -16. Oh, what was that? Okay, anyway, sorry. You can do this one here. It's 21 minus 16. 5. Plus 3. 8. There you go. So the new slope is 8. You have a point. That came out strangely. You are given a point. So can somebody give me the final answer in point slope form? You've got your slope and you've got your point. Use them. Go.
Y minus 4
Y minus 4
equals 8.
8 parentheses
X minus 4x, yeah,
x minus -1. You can also do x plus 1. And that's your answer. Find the tangent slope, find the tangent point, and use them. Clear? Did that get onto the answer key, that the point slope version? The computer generated it into slope intercept form. There's supposed to be a point slope underneath that. Did that print out? Okay, good. Next. Got about 25 minutes, so get about 5 more problems. Maybe. 15. Got it. Find the intervals on which each function is continuous. Again, continuous, you don't need any calculus on this. You just need to know where the function blows up. Can somebody name the 3 things that would interrupt a graph? Yeah. Holes. Yeah, holes, vertical asymptotes, definition breaks. And the one we don't have to worry about is definition breaks. So tell me, in this particular problem, alphabet is number 15. F of x equals, it's x minus 8 on top, and then x squared plus 3x on the bottom. Can anybody spot any discontinuities? Holes, vertical asymptotes, definition breaks. Go. How do you know? There's one little thing you have to do first. Factor the bottom. You don't have to factor the top. I mean, you could find holes that way. But the bottom factors to, how do you do it again?
It's x parentheses x plus 3.
Right, there's a GCF of x. So, what sort of objects are you seeing?
Vertical asymptote. X equals -3.
Yeah, vertical asymptote at x equals -3. And there's another one. Let me see it. X equals 0. That's this one. So if the graph blows up at 0 and blows up at -3, where does it exist? Where does it not blow up? Give me interval notation. By the way, feel free to sketch. It's kind of like plus minus notation. You don't have to do the whole thing. Give me the intervals where it actually exists. I see 3 intervals. Becca, take over. From what to what is the very first interval that's good?
From -infinity
Negative
to
infinity.
-3.
To -3. What kind of brackets?
Round.
Round for both of them. Round for infinity because you can't catch it. Round for asymptote because you don't want to include it unless you die. And then
Union.
union.
-3 to 0.
Okay.
Round brackets.
Round brackets.
Union.
Oh.
0 to infinity.
0 to infinity.
Round brackets.
Round brackets. There it is. That's your answer number 15. Does that make sense? So know how to factor and factor the bottom. That's going to be the main part where it's going to blow up, if at all. If I just gave you a problem like this, just hypothetically, everybody look up here for a second. Do you see this problem here? If I had said here, find where this is continuous, what would you say?
Negative infinity to positive infinity.
It's a continuous everywhere. It doesn't blow up anywhere. It'd be from negative infinity to infinity. Exactly. In other words, the only time it's discontinuous is if there's a whole vertical asymptote definition break. If it's just a plain old graph with none of those, then it's continuous everywhere. Then you can just go from a negative infinity to infinity. Next. Yeah, please.
For number 8,
Uh,
for quotient rule problems, do you want us to multiply out the bottom part?
Oh, good question. On number 8, the quotient rule has f prime g minus fg prime over g squared. The question is, do you have to expand out the g squared? No, you do not. Just leave it as parentheses squared. It's much faster and much easier to grade, frankly. And the question is, do you have to simplify it? Or can you leave it as something parentheses, parentheses, minus parentheses, parentheses over parentheses squared? Yes, you can leave it like that. You do not have to simplify that mess. As a matter of fact, on AP Calc tests, they don't require you to simplify that either. Next. Yeah, Sam. 16. Optimization problem. The rancher. Alrighty. Let's get some sheep. A rancher wants to construct 2 identical rectangular corrals using 200 feet of fencing, and the rancher decides to build them adjacent to each other. I don't know how often the rancher would use the word adjacent, but whatever, mathematical one. So they share fencing on one side. The drawing should look like this. You can also do it sideways, it's totally okay. Now, the dimensions on this thing are unknown. This is kind of up to you, your mileage may vary, but I like the up-down one to be y, and I like the left-right one to be x. Here's what I did. There are 2 of these, so I just put x and x. There's no problem with making the whole thing x. You'd have to use this distance as being 1/2 x. I just don't like fractions, so if I can avoid them. I mean, I like fractions, but I don't want to take them home to mom. So, question, fence, how much? How much total? Nick, according to the problem. 200 feet. According to the picture, what if you add up all the fence lengths, what would you get? Like, how long is this?
X.
X. How long is this?
X.
How about this?
1.
And this?
1.
Add them all up.
3y X.
Yep. 4x plus 3y should add up to what?
200.
200. That's a key to this problem. Your fence should add up to 200, and it should be 4x plus 3y. Now, you can use whatever variables you want. I just like x going left, right, and y going up, down, because it makes more sense to me. So, what are they trying to do? Megan, what's the objective of this problem, number 16?
Maximize the area.
Maximize the area. How do you maximize things in calculus?
Taking the derivative and setting it equal to 0.
Right. Take the derivative, set it equal to 0. That'll find maxes or mins, depending on what you need. I need an area formula. So, Josh, what's an area formula? If I use this particular setup, area equals what? How do you find the area of a rectangle? Yeah. So what's the length? 2x. Very good. And then the width? Y. I want to take the derivative of this. Why am I hesitating? I'd love to just take the derivative and set it equal to 0. I can't. There's x and y. There's too many variables here. There are 3 variables total if you look at this side. I mean, a prime, that's nice. But I have no idea how to take the derivative of a 2-variable problem. Is there a cure for that? The only problems we've ever done are one variable problems, like something equals a one variable problem, yeah.
We do substitution.
Substitution, take x or y by itself, I don't know, what do you think? What's your favorite?
Y.
Doesn't matter, y, okay. So, let me write it over here, 4x plus 3y equals 200. Get y by itself for me, what do you get rid of first?
Subtract 4.
Yeah, subtract 4x on both sides. Hang on. So 3y equals negative 4x plus 200. Keep going. Divide by 3. I would divide everything by 3. So you get y equals negative 4/3 x plus 200 over 3. That is y. Oops. I don't want to take the derivative yet. So the new area formula is 2x times negative 4/3 x plus 200 over 3. That simplifies just a little bit. Becca, how can you simplify this?
You can distribute.
Distribute. Go for it. What's 2 times negative 4/3? Is really 2 over 1.
Negative 8 over 3.
Yeah, negative 8 over 3, and then times what?
X squared.
Very good, x squared. Then plus
400 x over 3.
400 over 3x. And you can put the x on top if you want. That's the area formula. Everybody still okay? That is the second and most important key of this problem. Getting it down to a one variable problem. So let's take the derivative. Sam, go for it. What's the derivative of this?
Negative 16 over, is it just 3 or it's
You tell me.
6? 3.
3. And if you multiply by a whole number, it's always over 1. So 16/3 is what?
X.
X plus
400 over 3.
400 over 3. That is your derivative. What do you do with that derivative? Josh?
How would you set that equal to 0?
Set it equal to 0. Exactly. Do it. We've got negative 16/3 x plus 400 over 3 equals 0. Now what? Yeah.
So you could subtract 400 over 3.
Okay. So negative 16/3 x equals negative 400 over 3. All right. Now what?
Would you divide by negative 16 over 3?
Right. There's two ways to do it. You can multiply by 3 to kill the fractions and go, or you can just in one step divide by negative 16/3. How do you divide by a fraction? These cancel.
Multiply by the reciprocal.
Which would be what?
3 over negative 16.
3 over negative 16. Does anything happen over here?
The other 3's cancel.
Yeah. And whoops, I smeared the 16s, right? Does anything reduce? Anyway, I'll just open this up. The negatives cancel. 400 over 16. Go.
25.
I'm sorry, what?
It's 25.
25. X equals 25. Are you done with the problem? No, but you are 95% of the way done with the problem. You have just found x is 25. So what's the total width on this thing? Don't work too hard. 50. Yeah. Now question, in this problem, are they talking about the total or each individual corral? Read the words carefully. Something near the bottom will tell you. Let me see, yeah. Which one? Last sentence. Go.
Individual.
Individual, what told you?
It says, what dimensions should the rancher use to construct each corral?
Yeah. What dimension should the ranchers use to construct each corral? That's more than one. So they're not going to use 50. It's good you know that, the 50. But they're looking at 25 by something. 25 by what? Yeah. How do you find it?
I just knew that the top was also 50 and then there was.
Well, the top is 50 across. I want to know how far down. It's not
Well,
necessarily a square.
Yeah, I don't know how I did it, but I got 50.
You just know,
Yeah, that doesn't gonna fly. So it's like, I think in my heart it's 75. That doesn't work with calculus. So there is a way to find out. Is there any formula on the board that tells you how to find y? Yeah, it's right there. Use it. Now you can also use this if you think it's easier. Totally up to you. These are both equally legit. I mean, take it back. No.
I'll use the top one.
I would too. Okay. So it's now 4 times 25 plus 3y equals 200. Go for it.
100 and subtract.
Subtract 100, so 3y equals 100.
And then 5
Divide by 3, what do you get?
50. No, not 50. Like,
You're on the right track, but does it come out evenly? No. What are you supposed to do then? What's 100 divided by 3? Don't overthink.
33.
You're right. Leave it as 100 over 3. It's 33 and a third, but 100 over 3. Give me your final answer in words using units. What by what? Please.
25 by.
25 what?
Or feet,
Feet by
100 over 3 feet.
100 over 3 feet. That is the answer to the problem. You can also do 33 and a third. Questions? And that should match the answer. Questions? Now, does everybody see why we only used one of the corrals? It did say for each corral, not just for the total. Okay. I have time for maybe 2 or 3, depending on how fast we go. Oh, by the way, last 4 minutes. Actually, let me give you priority to the ones, any other questions you have on the test. Otherwise, I do want to give you a hint on how to do some of the extra credit. Yeah,
Can you do number 6?
number 6, yeah. Yes. The secret to number 6 is everybody got this stuff? Notes? Okay, I'll use this side. I have to stick to the middle board so the video captures it. Y equals 1/2 x to the 4/5. Plus 6x to the 4th 7th. Make sure it's in derivative friendly form before you try this. It actually is. So they want to find the derivative of this thing. They want the first derivative, right? I think. Yes. This is the part where the answer key actually went farther than they had to. I'll show you 2 versions of the right answer. Y prime, what's the rule here? Actually, we're going to take this one. What do you do with these? Multiply. What's 1/2 times 4/5? 4 over 10, which reduces to
5 over 2.
other way around. 2 over 5. And then what's the new power? How do you find the new power?
Subtract it.
Yeah, subtract 1. Now it's a little less than 1 as it is. What's 4/5 minus 1? Yeah, negative 1/5. You can kind of think of subtracting 5/5. So x to the negative 1/5. And then plus, somebody else take the second one. Megan, take this one. Multiply.
24 over 7.
24 over 7. X to the
Negative 3 over 7.
-3 over 7. I'll let you leave it like that. What they did was take the negative thingies and cram them in the basement. You do not have to do that. This is perfectly acceptable. But the answer keys version is also acceptable. Questions on that? Next. Any others? Going once, twice. Yeah,
Let's go
5.
5.
It's, that, yes, get it in derivative friendly form first. And that one is not. Number 6 was lucky enough to be. Number 5, y equals 7x to the negative 1 plus 2 over 5x to the 8th. You tell me. This is in derivative friendly form, basically coefficient, base, exponent. This one is not. Can you fix it for me? This is fine. Plus what? I'll give you hints. You can pull any constant in front. So 2/5.
X to the negative 8.
Very good. Now take its derivative. Do it.
So it'd be negative 7x.
To the what?
Oh, the negative second.
To the negative second power. Good. You'll lower the power by 1. Plus, go for this one.
Negative 16 over 5.
Good.
X to the negative 9.
And you can leave it like that. That's perfectly fine. This makes sense. All right, I want to give you a teaser about the extra credit problems. Number 17, logarithmic differentiation. It seems like a magic trick. Does anybody remember your log rules? We went through about a month ago. Does anybody remember this one? What is the log of a to the b power? This is rule number 3. What do you do with an exponent? What does it slow down to? It is b times the log of a. It's multiplied. And the reason you don't have a log b times log of a is because b is so small it can't carry its own log. So, this rule allows you to take, let's say, y equals 4x to the power of x squared. This is really weird. X to the power of x. How in the world do you take a derivative of that? You don't. Take the log of both sides. As a matter of fact, I'm going to take the natural log of both sides, just because calculus likes it. So ln of y equals ln of 4x to the x squared power. Jot that down if you want to try this. Here's where the trick comes in. Rule 3 says you can move this in front. Now take its derivative. You might say, wait a minute, I didn't get the logs out of the way first. You don't have to. Derivatives will smash any logs you have. Does anybody remember what the derivative of a natural log of x is? Because I kind of sort of asked this on problem number 4. Yeah. 1 over x, correct. In this case, it would be 1 over y dy equals, and this is the product rule, f prime g plus fg prime. So it's 2x times ln of 4x plus x squared times 1 over 4x times 4. There's a chain rule stuff here. Okay, so it looks like this. 1 over y dy equals 2x ln of 4x dx, right? Plus x squared over, so 4x squared over 4x dx. The 4's cancel and one of the x's cancel. So it looks like this. 1 over y dy equal to 2x ln of 4x dx plus x dx. Now, I want to get dy over dx by itself. Implicit differentiation, you find that. Divide everything by dx. Cancel, cancel. Let me put it up here. It's going to be 1 over y, dy dx, over dx, equals 2x, ln of 4x plus x, and that's pretty much it. Now multiply both sides by y, and you're pretty much done. Dy over dx equals y times 2x ln of 4x plus yx. The only last catch is, we know what y is. Put it back. So the final answer is 4x to the x squared times 2x ln of 4x plus 4x to the x squared times x. And you're done. I will leave that up and I'll put it on YouTube. Tell you what, I will try my best to post an additional video from home about how to do the second and third extra credit questions. So I'll try and get those posted by 7 o'clock tonight. Right? No, we have parent-teacher conferences. I'll try and do something. I have like a half hour before I start parent-teacher conferences. Maybe I'll do another video on this. I'll get it up there somehow, come purgatory or high water. All right, please stand. And let us pray. In the name of the Father, of the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. All right. See y'all later. Thank you.